Alright, so for section 2.6, we're going to talk about combinations of functions and composite functions. So with the combinations of functions, ways you would put functions together would be to add, subtract, multiply, or divide them. But we're going to run into a couple of potentially interesting problems whenever we start talking about the domain after we're combining functions. So let's first look at find the domain. So remember, there's two big main rules in this class. So in this class, we need to make sure that, one, we're not going to divide by 0. And 2, we are not going to take the square root of a negative. So these are the two things that we're going to keep in mind. I do want to talk about number 2 a little bit. So in the future, we're going to actually talk about complex numbers and imaginary numbers, which will be taking the square roots of negatives. We will not be taking the square root of any negative numbers for functions or for this section. So for A, to figure out what our domain is, let's first figure out what our restrictions are. So we know that we can't divide by 0, so that's going to mean that this x minus 4 is not 0. So if we add 4 to both sides, we're going to have that x cannot be 4. Well, this is the restriction, that's not the domain. So if we look at a number line and we have the number 4, then we can have everything except number 4. So everything above it and everything below it. This is showing us our domain, which is going to be from negative infinity to 4, not including it, so we're going to use a parenthesis, and then from 4 to infinity. And because it's this and this, so because it's both of these intervals, we need to make sure that we put a union here. So this is going to be the domain for A. All right, now let's go through and do the same thing for B. It's a similar idea, it's just going to take an extra step. And that extra step is that we're going to need to factor the bottom so we can start to find out what our restrictions will be. So we take this x squared minus 2x minus 15, and we know that that will not be equal to 0. So we're going to factor this so we can figure out what values actually make it 0. So it's going to be a positive 3 and a negative 5. So positive 3 and a negative 5 are going to multiply to a negative 15, and they're also going to add to this negative 2. So we're going to take each of these and say, okay, well then that means that x plus 3 can't be 0, and that x minus 5 can't be 0. So that means that x cannot be a negative 3, and x cannot be a positive 5. So if we're looking at a number line, and we've got a negative 3 and a positive 5, and we know that it can be everything except for those values, and it's going to be everything below negative 3, everything between negative 3 and 5, and everything greater than positive 5. So that's going to make the domain from negative infinity up to negative 3, and so we're going to use union, negative 3 to 5, and, so again with the union, from 5 to infinity. For C, this is where we're taking in our second idea that we can't take the square root of a negative. So if we can't take the square root of a negative, that means that what's underneath here, that 24 minus 2x, is going to have to be greater than or equal to 0. We can take the square root of 0. Square root of 0 is just 0. So if we have that the 24 minus 2x is greater than or equal to 0, and we go through and solve, we're going to subtract 24 from both sides. So we're going to have negative 2x is greater than or equal to negative 24. And then we're going to divide both sides by negative 2. hopefully you're going to have some bells and whistles going off right here. Because whenever we're dividing by a negative, that means we're going to flip our sign over. So we're flipping our sign over. So we're going to get x is going to be less than or equal to 12. So remember, flip your inequality signs whenever you multiply or divide both sides by a negative. So x being less than or equal to 12 is going to mean that we can include it. So we're going to use a bracket and then everything below. So one of the questions that I've gotten on this particular problem is, well, we can only have positives and 0 underneath our radical. So where there's 24 minus 2x's. So if we can only take the square root of a positive or of 0, then how is it that we have so many negative values for x? Well, and that's a really good question. So what's happening, whenever we plug in negative values for x, we have minus 2 times a negative. So what ends up happening is we have a double negative that's going to make it a positive number. So for instance, if we just want to look at a quick example, if we did f of negative 3, then that would be the square root of 24 minus 2 times a negative 3. So that's going to be the square root of 24 plus 6, which is going to be the square root of 30. And that would be our answer. So f of negative 3 would give us 30. So there's where we're plugging in a negative value, and we're getting a perfectly good answer. All right, now let's look at D. So D is one step trickier than either of the, or than any of the ones we've looked at. So D, there's a square root, so we have to remember that we can't take the square root of a negative. And additionally, we have to remember that we can't divide by 0. So we can't have this equal 0 on the bottom, which means we can't have this inside equal 0. So that means that this x minus 3 has to be a positive number. So x minus 3 is going to have to be greater than 0. And then when we go through and solve, it's super quick. So we're going to get x is greater than 3. And on a number line, we have our 3 here. So greater than, we're going to have parentheses and then go above. So it's going to be from 3 to infinity. All right, let's talk about the combinations of functions. So if we are combining them, we can do the sum, we can do the difference, so we can add them or subtract them. We can do the product, which is going to mean multiply, and the quotient, which is going to mean that we're going to divide. So whenever we're doing this, the domain for these combinations is going to be the domain where the domain of f and g intersect, meaning it's going to be where they share domains. And whenever we're dividing, we're also going to have the stipulation that g of x cannot be 0, because again, we can't ever divide by 0. So let's look at this first one. So let's look at A. So we'll go through and we're going to add, subtract, multiply, and divide. And before we go there, I'm going to go ahead and let's look at the domains. So for f of x, we have 8x over x minus 2. Well, that means that x minus 2 cannot be 0. So x minus 2 is not going to be 0. So that means that x is not going to be a positive 2, because we're going to add 2 to both sides to solve there. And then for g of x, x plus 3 cannot be 0. So x plus 3 is not going to be 0. So when we solve, we're going to subtract 3 from both sides and get that x is not going to be a negative 3. So on a number line, when we've got that negative 3 and that 2, so the f of x, which I'll do in green, is saying everything except for 2. So that's saying everything except for the number 2. And then the g of x is saying everything except for negative 3. So I'm going to do that in purple, in blue. So everything except negative 3. So it gets a little bit difficult, but we're just looking for where the lines, where both of these colors are. So the domain for f and g, so the domain is going to be where they're overlapping or where they share. So the domain of f intersected with the domain of g. So everything up to negative 3 is shared. So from negative infinity to negative 3. And then we can't include that negative 3 because there's no blue here. There's just the green. So f of x is not defined at negative 3. And then from negative 3 up to 2. And again, we can't use 2 because the g of x is not defined, the f of x is not defined here. The g of x is the one not defined over here. And then everything above 2. And again, we're going to put unions in between. So it's saying this interval and this interval and this interval. So this is the domain for the composition of functions for whenever we add, subtract, and multiply. All right, so let's do the first one. So the addition, we have 8x over x minus 2 plus 6 over x plus 3. And so to combine these, because we have rational expressions that have different denominators, so basically that just means we've got big nasty fractions that the bottom of their fractions don't match. We're going to make them match by getting a common denominator. And the common denominator is going to be x minus 2 times x plus 3. So this one is going to need an x minus 2 on top and bottom. And this one's going to be an x plus 3 on top and bottom. So we're going to end up with 8 times x plus 3, 8x times x plus 3. Let me correct that. So we're going to end up with 8x times x plus 3 plus 6 times x minus 2 all over that x minus 2, x plus 3. And it wouldn't matter here if we did the x plus 3 and then the x minus 2. So the order is not important. So we're going to simplify the top by distributing first, and then we'll combine like terms. So we're going to have 8x squared plus 24x plus 6x minus 12 all over x minus 2 times x plus 3. And now we're going to combine like terms on top. So we're going to have 8x squared plus 30x minus 12 all over x minus 2 times x plus 3. And now we want to see if this would factor and that we could we'd be able to reduce with something in the bottom. So the way that I'm going to check that, by pulling up my calculator, and I'm going to go to mode and then equation, which is number 5. And then this is in the form ax squared plus bx plus c. So we're going to look at number 3. So ax squared plus bx plus c is 0. And we're going to put in the coefficients. So this is going to be 8 equal 30 equal and negative 12. And then equal. And what I'm looking for here is to see if the x values that would make it 0 are quote-unquote pretty, meaning that they're going to be whole numbers or they're going to be fractions. This is an example of a number that is not pretty. So whenever you're going through and getting these answers and you're having square roots, or if you're having imaginary numbers, things like that, we are definitely not going to be able to factor these. So that means this is not going to factor. So that's going to actually be our answer for number 1. And again, it's going to have this domain right here. So let's work on number 2. And this is when it has to subtract. So we're going to have 8x over x minus 2 minus 6 over x plus 3. And we're going to go through the same first step as we did on the first part. And we're going to get a common denominator. So we're going to have to multiply by x minus 2 top and bottom over here. And multiply by x plus 3 top and bottom over here. So we're going to end up with 8x times x plus 3 minus 6 times x minus 2 all over x plus 3, x minus 2. And again, it doesn't matter which order you put the factors in the bottom. And we distribute on top. We're going to have 8x squared plus 24x. And then here's the kind of tricky part. It's a negative 6 being distributed. So minus 6x plus 12 all over that x minus 2 times x plus 3. Oh, and I swapped them back there. Sorry, I didn't mean to do that. But again, it's not going to matter. And I will combine the like terms. So we're going to have 8x squared plus 18x plus 12 over that x minus 2 times x plus 3. And I'm going to go through and check the same way. So I'm going to go to mode, and it's equations. Number 5, it's in the form ax squared plus bx plus c is 0. So number 3, I'm going to put in my coefficients. So 8, 18, 12, and then I'm going to hit equal and see if I get something nice and pretty. And I'm getting imaginary numbers here. So definitely not something that we're going to be able to factor. So this is going to be the answer for the second part of this problem. All right, now let's look at the third part. So for the third part, we need to multiply. So it's the 8x over x minus 2 times 6 over x plus 3. And the multiplication here is actually quite simple. So we're going to multiply the top times the top, or the numerator times the numerator. We're going to get 48x on top, and on bottom I'm going to leave it factored. We'll have x minus 2 times x plus 3. And nothing's going to reduce here. So that's going to be done right there. And again, 1, 2, and 3 all have the same domain of where the domain of f and the domain of g intersect. All right, one more. Let's look at 4. The fourth part, we're going to divide. So I want to point out that f over g is the same thing as f divided by g. Because we're dealing with rational expressions, this, writing out this way, is going to make more sense. So we're going to have 8x over x minus 2 divided by 6 over x plus 3. And because we're dividing by a fraction, we're going to remember keep, change, flip. So we're going to keep the first the same. We're going to change from divide to multiply. And we're going to flip that second one over, that second rational expression over, or that fraction over. And if we look, we can actually do a little bit of reducing right here. So hopefully you see that this 8 and this 6 will reduce. So that 8 will become a 4. That 6 will become a 3. And so we're going to end up with 4x times x plus 3 over 3 times x minus 2. So this is going to be what the function looks like whenever we divide them. So this composition, or combination, excuse me. So that's what this combination of functions will look like. As for the domain, this one has the additional requirement that g of x not equal 0. So because the g is on bottom, the g of x cannot be 0. Well, g of x will not be 0. G of x is just this 6 over x plus 3. And we have that not equal to 0. There's no value of x that would make that equal to 0. To be able to have a value of x make g of x equal 0, we would need to have an x on top, or in the numerator. So, since that's the case, number 4 of this problem will have the same domain as parts 1, 2, and 3. So this will still be the domain for all parts of this problem. All right, now let's look at B. So for B, let me pull this up a little bit. For B, we're going to go through add, subtract, multiply, and divide, and we're going to discuss the domain for parts 1 and 2. We are not going to discuss the domain for parts 3 and 4 because it's actually something that we'll learn a little bit later in a different unit. So we're going to start off by adding. So for part 1, the f plus g of x, it's literally just going to be the square root of x plus 4 plus the square root of x minus 1. And we're done. We can't simplify this. The reason we can't simplify this is because the square root of x plus 4 plus the square root of x minus 1 doesn't equal a number or doesn't equal a variable. So if it equaled 0 or 12 or something like that, then we would be able to do some manipulating to where we could square both sides of the equation or add or subtract something from both sides of the equation and make it look a little bit prettier. But because we don't have that, there's no way that we can just square these square roots. So that's going to be done, actually. Now let's talk about the domain. So we know that when we're taking the square root, that it has to be non-negative, so 0 or greater. So we know that for the domain that x plus 4 has to be greater than or equal to 0, and also this x minus 1 has to be greater than or equal to 0. So we're looking for the domain of f and the domain of g. Whenever we solve here, we're going to subtract 4 from both sides and have that x is going to be greater than or equal to negative 4. And over here, we're going to add 1 to both sides and have that x is greater than or equal to positive 1. So whenever we look at this on a number line, and we look at f, so maybe f of x for that domain, so x is greater than or equal to negative 4, it's going to be a bracket here, and then everything to the right. And then for g of x, everything greater than 1, greater than or equal to 1, so x is greater than or equal to 1. It's going to look like this. So the area that they're overlapping, that they share, is actually from this 1 on up. So the domain of f intersected with the domain of g is going to be 1 up to infinity with a bracket with the 1. All right, let's look at number 2, or the second part. We're just going to subtract. So the f minus g of x. So that's going to be the square root of x plus 4 minus the square root of x minus 1. And again, this is done. Because it doesn't equal 1 or x or 12x or something like that, then there's no way for us to go through and simplify this. And this will also have the exact same domain. And for parts 3 and 4, we're not going to worry about the domain. So for part 3, the f times g of x, we're going to do the square root of x plus 4 times the square root of x minus 1. And because these are both square roots, we can combine underneath that x plus 4 times x minus 1. And really, the only thing we could do here to possibly simplify would be, the only thing we could really do here would be to FOIL out to where we had the square root of x squared plus 3x minus 4. But really, this isn't going to do us any more good than this version. So either one of these should work. And then for number 4, the f over g of x, so f divided by g of x, we're going to have the square root of x plus 4 on top over the square root of x minus 1 on bottom. So we can rationalize, but that's really going to be the only step that we have. So if we rationalize this, we're going to be multiplying by the square root of x minus 1 on top and bottom. And remember, we can always multiply by the equivalent of 1. So the same thing over the same thing is always the equivalent of 1. So on bottom, we have the square root of x minus 1 times the square root of x minus 1. Or the square root of x minus 1 squared, which is just going to give us x minus 1. And on top, we can combine these to be the exact same thing. So x plus 4, x minus 1. So the same as what we got for the answer 3. Okay, now I'm going to go in a little bit of a tangent to discuss domain. So whenever we're trying to find the domain, because we're combining functions, we're looking at where the functions overlap. I know this will cause some confusion for some of my students. So for instance, with this one, some students don't understand why it would be from -4 and up, and why it's this 1 on up. Because -4 to 1 is going to work for f of x. The problem is that if we pick something in between here, like 0, and we plug in to this combination, plugging in a 0 here is going to make it negative. Let's talk about this in really non-mathy terms. So let's talk about domain in relation to dating. So whenever we're dating, a lot of times people will look for people that make money, people that are pretty, and people that are nice. So we're to take all of these things and put them on a scale from 1 to 10. As far as importance, and maybe money rates a 7.5. So the person has to be at least a 7.5 on the money scale. Maybe as far as cuteness, we want them to be at least a 7. And maybe nice is our most important quality, so we want them to be at least an 8.5 on the nice scale. Well, if we look at our scale, going from 1 to 10, and let's say maybe here is 8.5, maybe here 7.5, and maybe right there will be the 7. And we were to put all this on here, well, the money we have at 7.5. So we are looking here on up. So this is representing all the people that we would rate a 7.5 on up for money scale. So let's put cute scale on here. So as far as attractiveness, we want them to be at least a 7. So now we've got the attractiveness on there also. So where these lines are overlapping, these are all the people that have enough money and are attractive enough to be good mates, or to be what we're looking for. And the people here, so between the 7 and the 7.5, where we just have this purple but no green, these are people that are attractive enough but don't make enough money. And then let's add in the nice factor. So they have to be at least an 8.5. So now, where this 8.5 is, this is what we're looking for, to where these people are nice enough, they make enough money, and they're cute enough. Here, these people, between 7.5 and 8.5, so these people are going to have enough money and be attractive enough, but they're not going to be nice enough. And back here, these people are going to be attractive enough, but they're not going to make enough money, and they're not going to be nice enough. So we're only looking for the area where all things are going to be met. All criteria are met. So with this, our dating domain, we would just be looking for people that were at 8.5 on up. And this is the same idea with combining functions, that we have to make sure that all parts of our function are met. So where this part will work and this part will work. So we're meeting all criteria. All right, let's talk about composition of functions. Now we actually already worked on this. We just didn't call it composition of functions. So we had examples like f of x equals 3x plus 2. And we would plug in the number 1 or plug in a number. And so we do 3 and then plug in a 1 plus 2, and we would get 5. But we also had examples where we would do f of maybe x plus 2. And that would end up giving us, plugging in this x plus 2 into the x, this would be like 3 times what we plugged in plus 2. So 3x plus 2, 3, what we plugged in plus 2, and then we would distribute, and we would get 3x plus 6 plus 2, and then finally 3x plus 8. So we would say that f of x plus 2 equals 3x plus 8. This last example here, this is actually a composition of functions where we have plugged this x plus 2 into f. So if x plus 2 is g of x, then this is f of g of x. So this f of g, so this is red f of g, where that circle is a small open circle about where a multiplication symbol would be, so kind of floating in the middle. So f of g of x also means f of g of x. Whenever you're saying of in math, it often means open parentheses. So f of g of x. You can also see g of f of x, which means g of f of x. So this would be plugging f of x into g, and this is plugging g of x into f. So let's look at this first example. So f of x equals the square root of x, g of x equals x minus 1. It's asking us to do f of g of x and f of g of 2. So for the first one, this f of g of x, I'm going to think of it as f of g of x, so with the parentheses. And like you would do with order of operations, you start in the middle and you work your way out. So we're going to be plugging into f of x, which says take the square root of whatever's in here, and g of x equals x minus 1. So we're getting that f of g of x equals the square root of x minus 1. Now it's asking us to do f of g of 2. So f of g of 2 can be rewritten as f of g of 2, and we can just plug the number 2 in here. So this is f of g of x. So to do f of g of 2, we'll just plug in the number 2. So that's going to be 2 minus 1. So the square root of 2 minus 1 is the square root of 1. And then the square root of 1 is just going to be 1. So f of g of 2, which can also be written f of g of 2 equals 1. Another way to do it, if we were to walk through, and again with the idea of order of operations, so f of g of 2, if we start in the middle, this is saying do g of 2. So if we did g of 2, g of x says take whatever you plugged in and subtract 1. So g of x is saying take x, subtract 1. So g of 2 equals, so 2 minus 1 is just going to be 1. So now instead of g of 2, I can plug in this number 1. So f of 1 equals, and this is where f of x says we're going to do the square root of x. So the square root of whatever we've plugged in. So the square root of 1, which will give us 1. So us walking through these steps, we're going to end up that f of g of 2 is 1. Let's look at one more example. And again, we're going to start off doing f of g of x, where we are plugging g into f of x. So f of x is 4, and then x, I'm going to leave parentheses, minus 3. So 4x minus 3, and whatever we're plugging in, we're going to plug in for x. So we're plugging in g of x, which is 5x squared minus 2. We'll simplify. So this is going to give us 20x squared minus 8 minus 3. So 20x squared minus 11 for our f of g of x. And then we need to do f of g of 2. So f of g of 2, we can do either way, but because we've already done the hard work doing the composition of functions, we're going to plug in the 2 here. So this is going to be 20 times 2 squared minus 11. So the 2 squared is going to be 4. 4 times 20 will give us 80. 80 minus 11 is going to give us 69. So that f of g of 2, which can also be written as f of g of 2, equals 69.